Once we're familiar with the rules of exponents, we're able to divide some polynomials. Now, we are going to focus on taking a polynomial and dividing it by a monomial. So, for example, 10x to the 8th plus 15x to the 6th divided by 5x cubed. Things get significantly more complicated when we are dividing by a binomial or a trinomial, and that's not something that we're going to look at right now. We're only going to focus on division of monomials. Now, when we have a polynomial divided by a monomial, it actually works out very nicely. We can take each term of the polynomial and divide it individually by the monomial. So we can actually split this up into multiple fractions, and then we can simplify each one on its own. The reason we're allowed to do this is technically an extension of the distributive property. When we're taking 10x to the 8th plus 15x to the 6th and dividing it by 5x cubed, we're really taking this binomial and multiplying it by 1 over 5x cubed. So by using the distributive property, we can multiply each individual term by 1 over 5x cubed, and thus we can divide each of them by 5x cubed on their own. Now, if you didn't understand that, that's okay, it's fine. I just wanted to provide an explanation for those of you who wanted one. But really, the rule here just says if we have a fraction and there's one term in the bottom and multiple terms in the top, we're allowed to split it up into multiple fractions with the same denominator, that common denominator. And then once we've done that, we can simplify each individual fraction. If we look at 10x to the 8th divided by 5x cubed, 10 divided by 5 is 2. And then x to the 8th divided by x cubed is x to the 5th. We know that we subtract the exponents in that situation. Plus, then in the other term, 15 divided by 5 is 3. And x to the 6th divided by x cubed is x cubed. Again, we subtract the exponents. And then we have our final answer, 2x to the 5th plus 3x cubed. All right, let's take a look at one more, and then you can go through and look at as many examples as your heart desires. Let's take a look at negative 12x to the 5th plus 9x to the 4th minus 6x cubed divided by negative 3x squared. Now, we're doing division, we're writing it in a different way. I've used the division symbol instead of writing it as a fraction, but those both are used to represent division, and so it's actually easier here if we rewrite this in fractional form. Negative 12x to the 5th plus 9x to the 4th minus 6x cubed all over negative 3x squared. And then again, we can split this up into 3 individual fractions. We've got negative 12x to the 5th over negative 3x squared plus 9x to the 4th over negative 3x squared, and then minus 6x cubed over negative 3x squared. And we can evaluate each of these fractions individually. Let's look at the first one. First, what happens when we have a negative divided by a negative? It becomes positive. Those negatives cancel. So then 12 divided by 3 is 4, and x to the 5th divided by x squared is x cubed. The next term is going to be negative because we've got a positive divided by a negative. 9 divided by negative 3 gives us negative 3. Oops. X squared, x to the 4th divided by x squared is x squared. Good. And then in this last term, it's going to become a positive because we are subtracting something that's going to be negative. So this becomes a plus 6 divided by 3 is 2, x cubed divided by x squared is x. And we've got our final answer, 4x cubed minus 3x squared plus 2.